In part 3 of this video, we'll be looking at the electronics and taking it for a little drive spin. So here's the wiring diagram we're going to use. Here's the battery, link, fuse, connected into the LED strip, and this is all running at 12 volts. These are then connected to the speed controllers, of which there are two, one for each side of the drive. These are then connected into a BEC, or a battery eliminator circuit, reducing the voltage to 5 volts. This goes into the receiver, and from the receiver we'll run the servo, and then two signal wires will go from the receiver into the speed controllers, making sure we can actually change speed on the speed controllers. So the wiring gauge on the battery is 16 gauge, which means we don't need to go any bigger elsewhere in the robot. And here's the battery eliminator circuit. This was used in the original Night of Ni design. As you can tell, it's been butchered and reused for other things ever since. So it's got the wrong connectors on it, and there's this great big join in the cable where it was just arbitrarily used for something else. So we'll clean that up and make the better job of that. Here's one I prepared earlier. So this is it resoldered, rewrapped and reconnected. So now we've put an XT30 on the end rather than what it had before, which is much more suitable for this particular robot. So here we have an LED strip that was cut off something else. I'm not entirely sure what, but we can connect some cables to this and see what colour this lights up as. And with the cables connected and a battery on the other end, let's see what we've got. And it's orange, which means it came off Bookworm, which is one of the featherweight robots that I also have. So here's the fuse I'm going to use. This is what's known as a MIDI fuse. Bit bigger than probably what I need for a Beetleweight, but it's all I've got, so I'll have to do. And these are the connectors we're going to use. So we have a XT60 which runs to the battery. We have a couple of XT30s, one of which will be for the battery eliminator circuit and one of which we'll use for a link. And then we've got bullet connectors, which are what we'll connect the speed controllers to. Everything is so tiny on a Beetleweight. And here's one I prepared earlier. Now I'm not going to go through a soldering tutorial. There are plenty of those on the internet if you're interested. But this is the loom. So we've got the link, the fuse, the connectors at the other end for the speed controllers, and the connector for the battery. And what we're going to do is we're going to run a continuity check with a multimeter. This is just to make sure that all the solder connections have taken and all the connections made throughout the loom are correct. Doesn't take very long to do, but it'll save you time in the long run. And these are the speed controllers we're going to use, which are 10 amp Simon K flashed speed controllers. They're cheap ones that were off Hobby King. I don't even know you can get them anymore. What we have done though is we've taken the power out of each of these. Because we're using a battery eliminator circuit, we don't want these to also power the receiver, because that way bad things lie. So here we are with the loom, and we'll fit that up into the robot. At this point we'll just kind of lay it out quite simply. Won't tie it down or anything because we've still got some testing and some checks to do. So here we go, let's power it up and see if it works. It certainly works. It's a bit fast though by the looks of it. But yeah, all seems good. So the final check we'll run is a fail-safe check. This is to check that if we turn off the transmitter, that the motors come to a dead stop. This is a safety feature always checked for when you go to events. All good. And so here it is with all the cable ties and everything around all of the connectors and cables. The receiver is kind of just taped in. I'm going to move that eventually. Not really happy with where it is in the robot at the moment, but it'll do for the time being. We'll do a final wheels off the ground bench test just to make sure, now that we put the lid on, that we haven't disturbed anything. Should be fairly safe at this point, but, you know, pays to check. And so here we are in the test box. This has got a polycarbonate roof on it, so you'll notice all the reflections. This is a test box that I'd otherwise use for spinners, etc. Because it's safe and contained. But a knee doesn't really need it, but pays to be safe, I guess. One thing I'll note: this is far too fast. The rates need changing significantly, and yeah, we're getting some really good wheelies out of it. That's because we've changed the battery from that really heavy battery to a LiPo. So there's no weight at all on the front end of the robot anymore. So it just wheelies like crazy. But we can fix that. We can put on some better wedge on the front or something that will weigh it down. And then checking for self-righting. Wonderful. And yeah, as you can see, it's pretty fast. So we'll need to change the rates of that. However, we've got plenty of weight left. So the intention is to put a wedge on the front and weigh the robot down at the front end to make sure that it doesn't wheelie quite so easily as it does in the demo.